Welcome back. This is Professor Needing with another thrilling, exciting instance of Math 068, and we're talking tonight about Section 6 linear relationships. You would have discussed linear relationships as a younger adolescent in middle school and most certainly in high school in algebra. And most of you probably will have some recollection of y equals mx plus b, slope, intercept, things like that. And those are the kinds of things we'll be referring back to this evening. So a couple of things here. So let's walk through them. I'll do a little jumping back and forth again, as I always do, between here and some written work on my doc camera. So when we talk about a y-intercept and an equation, what we're discussing is a Cartesian plane. And a mathematician named René Descartes, Frenchman, is surmised to have a little bit of anxiety issue, and he locked himself in his room for a very long extended period of time. And while lying around in his state of disarray, his room became very untidy and he got a lot of cobwebs in his room. And one day, as the story goes, he was looking at the connection between the cobwebs' vertical and horizontal intersections and developed from that the formalized what we refer to as Cartesian plane. So if we think about the horizontal axes, we refer to this as the x-axis. Any movement left and right. Moving from the center to the left is negative, from the center to the right is positive. The y-axis is the vertical change, and we have negative movement from the center downward and positive movement from the center upward. So anywhere we place ourselves, we have a coordinate, if you will, to move from. When we speak about Cartesian and plotting points, really this is so that you and I, in two completely different venues, can talk about some x and some y and get it onto a piece of graph paper and have it in the same location. So we have this original place in the center called the origin. And the origin is the connection between the x-axis and the y-axis, and it has no value at all. In fact, the origin itself has coordinates of 0, 0. Now you'll see that coordinate plane numbers are always given in the coordinate of x, y. X first, y second. These numbers can be whole numbers, they can be negative, fractions, decimals, they can be variables. They can be whatever we want them to be. They must be enclosed inside of a set of parentheses, which lets us know that that's what they are. And they must, again, be in the order of x, y. It says the first number for x on the horizontal, and the second number is the y, gives the vertical positions. And it talks about the origin being 0, 0. 0 because it has no movement to the left or the right, and it has no movement upward or downward. If we talk about an example point of 5, 4, that means that we have 5 units of movement to the right from the origin, and 4 units upward, again, from that same location or that horizontal 0. Negative numbers tell us to go left and tell us to go down. Now, notice that this box says alphabetical x, y. Well, why is that? Well, it's because we don't always use x's and y's. Sometimes we use, for instance, R and Z. We always alphabetize our letters no matter what the letters happen to be. And if I were to give A and B, I'm going to give both A's and capital. A and B would be A movement left and right, B movement up and down. It would correspond to X and Y, but it's labeled A and B. So it says to plot the following points are in the Cartesian plane. So we'll look at the first one here. The first one is 3, 5. That means from the center, I'll move 1, 2, 3, and then I'll move upward, straight up from that point, 5. This is point 3, 5. Little large, but it'll be okay. It'll work for us. Second one, 0, -2. That means 0 movement here, no, and go down by 2, right at the intersection. Not all points hit at the intersection. This could have been 0, 2.1. C, -6, -8. So I move 6 to the left. That's my negative. and I move 8 downward because, again, that's my negative. It's the intersection of the -6 and the -8. -4, -6. I move 4 to the left. This time I go 6 to the up because it's positive, and there's point D. Point E is 2, 9, 2, 9. And lastly, oops, sorry, that was 2, -9. 2 for E, -9. So you got to be careful, double check yourself. And the last one is 4, 0, right there. Also important to note that not only would we put points down here, but next to those points, we would then install also the letter that goes along with that point. For instance, letter F would be sitting right next to that dot. We don't have to write the coordinate, but we do need to write the letter that corresponds with it. Just like when I did 3, 5, I need to have an A sitting next to it. Or when I did -4, +6, I need to have a D next to it. We don't want to have to look for the point. We want to actually know what those point values happen to be. And again, if I just simply look at this one, 2, -9, that's point E. And if I look at 0, -2, that was my point B. And lastly, I'll go back to my last one, -6, -8, that was my point C. Cartesian plane is divided into 4 quadrants. Quadrant 1, 2, 3, and 4. Notice they go on a counterclockwise rotation. They always start in the top, and the signs are very specific in each one of them. Study the signs and know the signs of the quadrants. For the majority of the time in statistics class, we'll be in quadrant number 1, because the majority of things we deal with are positive by positive. It says, state which quadrant the following points are located into the Cartesian plane. This will be a student exercise for you. Refer back to here. Look at the points that you're given. So for instance, 3, 5, they're both positive, quadrant number 1. Definition says that x, 0, some number x and 0 is that lie on a horizontal axis is called an x-intercept. Anything that lies on the x-axis itself is an x-intercept, just like anything that lies on the y-axis is a y-intercept. Notice that a y-intercept has a 0 for its x-coordinate, and an x-intercept has a 0 for its y-coordinate. Find the x and the y-intercepts of the following graph. So when we look at this, and I'll do the first one for you, and we'll do the second one. So if I look at the x-axis, it has a value of 4, 0. You would not put a 4 here. You would put a parenthesis, 4, 0, parenthesis. Oh, my typing did a great job, didn't it? Sorry. Parenthesis, 4, 0, parenthesis. There we go. For the y-intercept, it looks like it hits at 8 at the y-axis. Now remember, the movement left and right is 0, +8, always in an ordered pair coordinate. I'll leave this one for you to do for part of your upload process and your grading. So in algebra, we often write a slope-intercept equation. You're probably familiar with this equation of y equals mx plus b. It's a pretty straightforward equation that's been utilized for quite some time. Now, when we talk about that, it has 2 very specific parts. First of all, the slope m. That is not always an m. I want to make sure that you understand that it can be anything. But what's most important here is it's attached to the x through multiplication. This m and this x mean m times x. Slope gets multiplied by x. X is, remember, our explanatory variable. I'm going to write that down. Oops, sorry. X is the explanatory variable. And I'll copy that. Now, when we look at the y value is super similar to that, but the difference in the y variable is that it's not the explanatory, it's the response variable. The b value is always the y-intercept, but again, it's not always a b. How do you know which one it is? How do you know it's not this one or this one? Because it's not attached to an x. There will always be an x and a y, or there'll be m times something here This will modify itself, and this will always be equal to some value, and this will be always by itself. The slope is the indication of how much rise and run that the line has. The b value, or the slope intercept, is where it crosses the y-axis initially. Now, notice that we can do a little bit of mathematics, and we can use what's called commutative property and turn some things around. For instance, if you're very used to seeing y equals mx plus b, then if I turn the equation around and I wrote y equals b plus mx, m is still the slope, even though now it's at the back of the equation. B is still the y-intercept, even though it's at the front of the equation. I'm telling you this because it's about to happen. Now, when we do this, we don't like to leave the y's, the m's, and the b's. Remember, I told you, don't get used to seeing the m's and the b's. So in statistics class, we use the equation of y equals a plus bx. Gonna need to know and be very familiar with this particular principle. The principle being that the y-intercept is the a value. Again, I would tell you to focus on the thing that's all alone on the same side as the letter being multiplied by x. The b is the slope, and you'll know it because it's the one, again, that's attached to an x. It's being multiplied by something. So I'll help you out with a couple of these student exercises down here, and then I'll leave you with another set. So what I'm going to do is I'm going to switch over. Actually, no, I'll be able to type right here. So what I'll do is I'll identify, first of all, from here, which one's by itself, A, and which one's with a letter, X, and that'll be my B value. So I go here. 1 is by itself. If 1 is by itself, it's the y-intercept. Remember, the y-intercept always has a 0, comma, something, so it's 0, comma, 1. The slope, the x has nothing to do with the slope. The x only helps us find the slope. The slope of this line is 2, because that's the y equals, think about it, a is 1 and b is 2. Not 2x, just 2. Next one, y-intercept. I look for the one that is not attached to the x. That's the 1500. So therefore, the y-intercept is 0, comma, 1500. I look for the one that's attached to the x. It's a negative 50. The sign of the number matters. I'll do one more. Actually, I'm going to leave this one because this is very similar to this. I'm going to go down to a letter one. Grade equals something plus something times something. Okay, well, remember, go back up here. This equals something by itself plus something times something. Let's find that something times something. 3.2 is being multiplied by study. Therefore, 3.2 must be my slope because it's being multiplied against study. Therefore, 41.2 has to be my starting value, so that's my y-intercept. Again, I'm isolating it because I can see this. So we're finding, think about this, grade is the same thing as y. This is the same thing as A, and this is the same thing as B. Y equals A plus B times X study. You can do letter E and letter F. When we talk about a slope, there's 3 things that can happen in a slope. 1, it could be negative from left to right, as in going downhill, always read from left to right. 0 is no slope at all, meaning no increase, no decrease, it's horizontal. Now, we don't say that it has no slope, it has no rise, and it has no run. So therefore, when we say it has 0 slope, it indicates no rise, no run. Do not use the words no slope. It has no rise, and it has no run. A positive slope goes uphill from left to right. So the definition of a line which is increasing as it goes up from left to right has a positive slope which is greater than 0. A slope could be 1, 2, 2.4, it could be 0.111. As long as the slope is greater than 0, it's a positive slope. It says, for example, if you were adding $100 to your bank account each week, as time goes by, the amount of money you are increasing by would be formulated by this 100. So therefore, the slope of this particular line would be a monetary value of plus 100 each 1 week. A slope is not just simply a value number, but it can be a number which is in context of some problem, and it looks as an increase in this particular value. If a line is decreasing or goes down, it has to be a negative number. That negative number is a number which is defined as m smaller than 0. Any negative value is a negative decreasing slope. And again, same kind of thing. Suppose instead of putting away money, you take $100 out each week. Now we have a decrease in $100 per every 1 week. It's very important to be able to talk about the context, and this is what it means, and this is context of a question. The context of this slope is a decrease of $100 each 1 week. If a line is horizontal, remember the slope is 0. It's not no slope. We would not indicate this has no slope. We would indicate there is no increase and there is no decrease. It would be a completely horizontal line. Even though that line looks a little skewed, let's say this is horizontal because it would be horizontal. And it even states it right here, horizontal. And in this particular one, dollars are not changing as time goes on. My bank account is staying exactly the same week by week by week. I'm not taking anything out. I'm not putting anything in. For each of these lines, determine whether it's positive, negative, or 0. Well, a line going downhill is always a negative slope. So this would be a negative value. A line going uphill would always be a positive slope. And a line going completely straight across horizontally has a slope of 0. I'll let you pick out the ones that correspond, but you're putting the graph letter with which ones are which up here. And you have 4 graphs, so you're going to have 4 letters up here. It says in student exercise 7, which of the following graphs called scatter plots, so these are all scatter plots, and these use the relationship between 2 quantitative variables, we saw that in the last section, have a negative slope, and which graphs have a positive slope. All right, so we have to be a little careful here on how this is going to be done. And I have to be able to draw a line, and I'm going to have a tough time drawing a line here, I believe. So what I'm going to do to you is I'm going to show you on a piece of paper what I think I would want you to talk about. So let me go to here, and let me grab for you that very same thing we're talking about. So here's what I'm studying. What I'm studying, or what I'm looking for, is the trend in these lines. For instance, if I were to put a line in the middle of the data, it would not be like this. It would not be like this. The trend is about like that right there. I'm trying to find a place where the dots hover around the line. What I'm making is what we would call a line of best fit. So if I were to pencil in a line coming down through here, that line would clearly be a negative slope. Now, it's not perfect, but it's not called a line of best fit for no reason. It's the best fitting line we could come up with, but it tends to go negative downhill. If I were to look at this line here, again, not like this, definitely not like this, take out that one right there, and you can kind of see that the data would do this. Remember, sometimes the extreme values or the outliers we don't look at, so I'm kind of ignoring that line right there. That's a negative line. This one clearly has a positive trend. You can see it right away. It kind of goes up like that. This line, again, very trendy, and that trendiness is upward, again, in a positive direction. You can pick up positive and negative trends pretty quickly when you look at data. Now, some of the data could be so skewed and so messed up that you can't even come up with a value for it. Now let's jump back here and let's see what we have. Went through all those. Oh, here we go. And that one there, I'll let you do that one. When a problem involves a constant rate at the beginning of an amount, it can be written in the slope-intercept form. We already saw this, y equals mx plus b. But it can also be written in the form of y equal abx. Remember, we switched it. So we also know that we can type something in y equals a plus bx, where a is the value of the starting position that we're speaking of, and b is the slope. Okay, it's exactly the same as mx plus b with the letters moved around. To do this, recognize that we will represent m as the rate, will represent the number b as the y coordinate. Okay, now we're going to talk this way when we do these, but we can also talk this way. I think we'll focus on this because this is what you're going to do in class and for all of your assignments. A plumber charges $50 to make a house call. So first thing I would tell you is that's important because he's going to do that one time. That $50 house call is a one-time kind of thing that doesn't repeat itself. Then we're going to look for something that actually does repeat itself. He's going to charge $25 an hour. Wow, that thing got really big. $25 an hour. I'm going to move that right here. That's a repeating value that's going to happen over and over and over and over again. Write an equation that you could use to find the amount the plumber charges for a house call based on the number. So what we're looking for here is amount charged. Since we have context, we use context words. We don't write y equals. Now, what I am emulating, though, is I'm emulating y equals a plus bx. That's what I'm actually doing. But instead of y, I wrote amount charged. Okay, now, what's the a value? Okay, what did the problem start with? The problem started with $50. You're going to take $50 and you're going to add it to the bx. Well, what's the bx? The b is the slope. The slope is $25 times every x, not every x, times every hour. This is the y equal abx equation in context. Y, the amount charged. B, the starting value. Oh, excuse me, A, starting value. B, the slope. The letters A and B really are meaningless, and so are the y and the x. The only important part is the x is the explanatory, the y is the response, the A is the starting position, and the B is the slope. How much would it cost for a house call that requires 2.5 hours of labor? All right, well then all we're really going to do is we're going to go in, we're going to put, okay, amount charged is going to be equal to, remember we're going to use $50 because we're going to start with that. And then we're going to add 225. And now we're going to multiply it by 2.5 because 2.5 is the number of hours that we increased. So put that in a calculator all in one line, make it all happen at one time. And $112.50. You would use context, $112.50, and 50 cents for a 2.5 hour service call. Another L, service call. There we go. If the bill from the plumber was $162.50, okay, well now we know the amount charged. So now this changes. We know he charges us $162.50. Okay, well what did that come from? That came from a $50 initial charge, plus it came from some number of hours times $25. So it's 25 times some number of hours. We subtract 50 from the $162.50 because algebra says that we're trying to isolate the variable. So we get that down. So we take that value down from there and we bring it back to $50 would be $112.50. We divide by 2.5 and sorry, my battery on my pen was about to die and I had to switch back right around. So I'm back at you. Whoops, hold on a second. Right here. Okay, so we were $162.50 was equal to 50 plus 25 times every hour. We subtracted the 50 from the one side of the equation and we wind up with 112.50, and that's still equal to, remember, 25 times the number of hours. Now we divide both sides by 25, and you're going to get 4.5. Thus, the answer is 4.5 hours if the bill was $162.50. Nice if I could type faster. Do the same type of thinking for exercise number 9 and exercise number 10. Be careful in number 10 that it talks about feet tall, and make sure you're speaking in inches, okay? I'll help you with number 11. It says a regression equation to predict a grade on an exam from a number of hours spent studying is the grade is equal to the starting value plus 3.8 times the amount you study. And the amount you study is hours because it's up here in the problem. What grade will a student receive if he or she studied for 10 hours? All right, well, I'm going to type out what I would actually write. So again, I'm looking for the grade. I'm going to always have 41 in this particular one, plus the 3.8 times the number of hours studied. The number of hours studied is 10. So in essence, 10 times 3.8 is 38. 38 plus 41 is going to be 79. So the grade of 79, and it doesn't say it's a percent. It just says 79. It doesn't, it just says the grade. Grade of 79 if student studies, and it was 10 hours. And this is an approximation. This is what we call a prediction. How many hours will a student need to study if he wants a 92? All right, well, we just flip it around. 92 equals, remember, we're starting with 41. We're adding that 41 to 3.8, and that 3.8 gets multiplied by the number of hours. And mathematically speaking, I'll show you here. Mathematically speaking, we're going to take that initial value, and I think I can actually do a nice little split screen here. Give me 1 second. Split screen, and let's put that thing to the left-hand side. Let's put the calculator on right there. Actually, let's do this calculator. So we have that calculator. So remember what we're doing here. We're taking 92. We're subtracting 41. 92 minus 41. That's what happens when I isolate the variable. And then I divide that number by 3.8. And I wind up with approximately 13.42. And it says, how many hours will a student need to study? So the answer is going to be approximately 13. And I don't know how many decimals we want to keep. I don't really know that it matters. We had 13.42, so we'll just say 13.4. Approximately 13.4 hours of study time. It doesn't have to be those exact words, but it does have to be words, okay? That brings us to the end of this particular chapter. This would be a great time for you to formulate your upload for your next chapter and get all those things turned in. If you have any questions, feel free to email. Thank you very much. Have a great and wonderful rest of your day.